have online venous saturation monitoring because in ECMO venous saturation may not be accurate because there must be some recirculation, but in a we know arterial ECMO definitely this is going to be more helpful because your entire thing is going to get guided with the help of venous saturation. You are going to plan your flow and everything depending on the venous saturation, so this is going to be more important in a VA. Then you have inline continuous blood parameter motor CD. I think that's not available in India, so but then that can you can online you can monitor all the oxygenation, bicarbonate, temperature, hematocrits. This is a sensor which you have to put in the sheet to measure these levels, and this is a range in which it gives you blood gas reports. PCO is 10 to 80, PO is 10 to 500. That's about 10. All you got it will measure how much the flow is going. But what you are is basically because it's a centrifugal technology, the flow keep on changing depending upon the preload and afterload. So you might have to adjust the flow. So that is most important to measure flow. The flow sensor is separate and that can be attached anywhere in the circuit. Only thing in my case that has been attached to the pump itself. So the problem with that is suppose we have a VAV ECMO. In that case, we find it difficulty to measure how much is the flow going to the artery and how much is going to the vein because it will measure only the flow which is going out of the pump. So that is a disadvantage of that. You can measure the flow here, hematocrits, venous saturation, and saturation. They are even bubble detector also. This is a Medtronic machine as well, bubble detector, ultrasonic inbuilt, but we have purchased it in long back, but then nowadays we are not. This is an auto clamp, it's available in the machine. Moment the bubble detector detects the bubble, the auto clamp you not go. But then that is what is bubble treatment. So that is what used to create a problems, and that's the reason we stop using this. This is the auto clamp unit. What microboards are very small, they are not there, so that there is no plasma leak and it can be used for longer time. Then it has to do with the roller pump which has been used during CPV, but then the concept of centrifugal pump has come, and now almost all the centers, something all over the world is using centrifugal pump as a for the ECMO. And this is how the circuit is going to be. Solid hollow venous end on the patient, okay, which is going to the pump, going to the oxygenator and coming back to the patient. And it means there are different conductors to measure the different pressures of the circuits. So now no directly from roller pump, impeller, centrifugal pump, and nowadays everybody is using centrifugal pump. Roller pump used to be in OT with a dependence. So what happens if there is a decrease in preload, it can suck the RA or IVC and can cause vascular damage. So that is most that's why you should have bladder box or servo regulator, so that if the preload decreases, basically the machine stops, so that it doesn't cause suction effect. Centrifugal pump is used for long-term ECMO, and usually we don't require to use servo controller for centrifugal pump because that can the flow will keep on changing depending on the preload and afterload. So as Sir told before, Dr. Povani, that roller pump is a centrifugal So roller pump is an exclusive pump that is used in cardiorespiratory bypass, and it works by mechanical pressure displacing the tube. So it compresses the tube and thereby pushing the blood to the raceway. The problem with this is when it goes to number of times, it can cause damage to keep on changing the tube, so that with the help of RPM, the flow is not proper, it's too light, then it will calculate the flow falsely, or too tight, the flow will calculate it wrongly. The advantage of this is it is a constant flow, it is independent of your preload and afterload. Priming volume is less as compared to centrifugal pumps, lower cost, and people have got more experience with the cardiothoracic department, have got more experience with the lower pump than the centrifugal pump. This is, as I told you, rupture, degradation of plastic particles. Too little occlusion will give false elevated flow. Too tight occlusion will lead to more of a spallation and that is with the roller pumps. Now, most important centrifugal blood pump, which we usually use it for the ECMO. It is a preload and afterload dependent flow. Okay, it depends on the pump preload, pump afterload. The flow will depend on the pump preload, pump afterload, size of the biohead, and the pump speed. So it depends on RPM, preload, and afterload. So flow will reduce automatically if the preload is decreased or afterload is increased. The flow will decrease automatically. And it has got a hand crank and has a battery backup also. So advantage, it requires less positive pressure. It sucks the blood in the confined vortex. So it traps a small amount of air also, so that chance of air emulsion decreases. Okay. And it avoids the extreme buildup of pressure so that the tube can rupture. So almost tube rupture is not seen with a centrifugal pump. The disadvantage is the flow will keep on changing if there is a change in the preload and afterload, so flow may not go proper. And If there is too much of suction effect, then it can lead to cavitation and thereby causing formation of air in the circuit itself. Okay. So because of if the pressure becomes then minus 100, then it can give us cavitation and can lead to air embolism. The different types of centrifugal pump, biopump, and centrifugal pump. The problem is which the all centrifugal pumps are types, the machine specific, so they can fit only into that type of machine motor head. Otherwise, it does not fit. So you cannot have a pump of Medtronic and that will fit into Magnum machine. No. So you have to have by the same company pumps, centrifugal pumps. Centrifugal pump, it is easy to set up, better results, air trap is always there, and no high arterial pressure that will lead to rupture. Roller pump needs bladder and venous regulation. This does not require bladder and venous regulation. It can generate high arterial pressure, rupture. It does not cause high arterial pressure. The only thing is it can give us negative pressure and thereby can lead to hemolysis and increase cavitations. Okay, so this is how the pumps look like. And then each and every pump has got their own specificity. This pump just rotaflow liters of flow. Okay. For 10 liters of flow. The primary is 30 ml. Okay. And the source of methane is less. So your requirement can also decrease. The Medtronic one. So this is the concept of the centrifugal flow pump with a vortex constraint. So this is the way it works. It causes suction effect, so it drains the blood. And so it's not gravitational dependent. The flow is gone from center to periphery, it will trap the air bubbles in the center. Again, it not allows us the air bubbles to pass on, or small air bubbles can be prevented to go over. इसका वॉल्यूम को जंप करना साउंड वॉल्यूम बंद किया सर लैपटॉप का हाँ लैपटॉप का चालू कर सकते हैं चालू और उसमें यार है ये ना हम देखेंगे तो यार चलो निकाल लो अगला भी लगा दो उसको करो यहाँ पे आप आओगे चलो 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 को तो नहीं बंद करना पड़ेगा This is basically a comparison between biopump and impeller pump. The flow, okay. Biopump will take the air bubbles in the center and not allow the pump air to go out. And this impeller pump can even lead to some kind of hemolysis, and that's the reason more of a biopump. This biopump basically has got a center of the vortex property. So see, the air bubbles are there. If at all they get trapped in the center and does not go to the periphery, which will not be there with the impeller pump. This Salient reversal pump, it has got a maximum flow of 8 liters, okay. And the connectors